Hey, hi. Yeah, there's a break for a while. Yeah, how many days? More than 10 days, I guess. Very bad. Anyways, we are back, so no issues. Only thing is, just because we took a break in between, we'll just catch up and see um, to where did we come. So, unfortunately, from last, I guess, 5 days or so, we are still in embedding only. Um, um, I can speed it up and then make it faster, but I don't want to do that because uh, embedding is pretty important. Usually, when we study, we skip things in between because of time constraint or something like that. Good part is I don't have the time constraint, um, so I should even if it takes time, even if it takes months also is okay. But I should focus on learning things properly so that the foundational knowledge about the generative AI, LLMs and stuff is very clear. Uh, the the main objective um, is to understand the put it in a simple way. How is generative AI able to answer questions um, in a proper language, and it is able to rewrite it basing on different scenarios as in ages and something like that. So um, uh, so it's able to so its ability to understand, the way I look at it is, generative AI is able to read, let's say, set of books, and it's able to understand all those books, and it is able to answer questions basing on the all language, or the text that is available in all those books. It is able to answer questions. Uh, so um, how is it able to do to the detail, and um, so and then we'll get into the other sides of the story, that is, how can we improve it, how can we make it better, how can we set up environments where we can run LLM models, how can we build agents. That is where we'll head to it. But before we go to that, more like an applied data science kind of stuff, we want to understand the foundational knowledge and basics of NLP, LLMs and stuff, so that we'll be having a stronger knowledge in generative AI. So, okay. With that being said, let's get to the current state where we are, what we have studied, and stuff. Bad part, we didn't maintain any metric on. Uh, we didn't keep a list on which all topics we are covering and stuff, so that if we have checkbox kind of stuff, we would have said these are all completed and this is still pending kind of stuff. But it's okay. I can recollect from embedding perspective. We clearly, um, one second, guys. One second. Um, just give me 1 second, guys. Let me close the door. Sorry about that. Oh, mm, okay, let's share the screen. Go to ChatGPT and get started. Let's find out where we have. Okay, here we are. Yeah, here is where we had some planning. Yeah, cool. But we have TF of attention transform. Very good. To be more organized, whatever topics that we are covering, if it is covered in some other course, we can also take that course, because this is going little dragged because I'm all over the place. I'm going to one, I'm going deep into it. Few topics. Going deep into it. Let's see. That's us for today. We'll focus on that. So, NLP. In NLP, lesson 4. Course 1, Welcome to Natural Language Processing. Course 2, Introduction to Natural Language. Web computing with natural language. No, this is not the same. I somehow doubted that NLP demonstrates high accuracy in specialized tasks such as syntax parsing and entity recognition. These LLMs can't do entity recognition and syntax parsing. That doesn't make sense. So without doing that, how is it understanding questions and then answering? Okay, fine, let's go. Efficiency more efficient. Let's go. Okay, this might be true. More efficient specific to the computational image. Requiring great computational resources. So much plus customer experience. Let's go. I'm expecting. The broad field focus on the interaction between numbers and yeah, see specific models within NLP designed to handle large scale text processing and generative tests. Okay. Then sentimental analysis NLP can do better than LLM is what you're saying. It's interesting. That's okay. Hmm. This is nice. So I think this is where we need to learn NLP, bring it to LLM, merge them together. For example, they are already doing like um, if they're taking text, image, and now limitation this limitation that is being called out as text, image, and video processing capabilities lacking in LLM. It is I think they're doing an ensemble technique there where they're using models from NLP to process these particular inputs and then give it as input to LLM and then they're extracting data again and stuff. This is nice. Few of them are being addressed, I'm sure. Sentiment analysis is something I need to get into the details where NLP can outperform LLM is something we need to do. Rule-based information extraction is also possible because reasoning LLMs in recent times with respect to agents, um, it's also is kind of an ensemble technique is able to do all this. I think that also it can do properly, but the boundary line in between LLMs and NLP is something we need to see. But if we segregate LLMs alone without having these additional capabilities added, as in because LLMs are trained on huge amount of text, so they can take input as text and output as text. Considering that fact, I agree with the option saying if it is input which is not text and then output expectation is not text, then it would not understand. That's agreeable. Reminding things like sentiment based analysis, rule based, task based parse, task specific parsing, speech recognition, and all that stuff. Um, that's where the agents are kicking in. Are the agents using multiple things, reasoning and task specific and stuff without extraction, task specific represent handle. That's what he's saying. So these frameworks integrate LLMs and traditional NLP techniques. You base on create one master and powerful applications. task super plans. Oh, it's using 4O, is it? Nice. This is what is being used. After some time, the tokens will expire and will not generate 4O. Okay, sounds good. I will continue with the NLP plan as is and then come to LLMs. So, but and the order that I wanna cover with respect to NLP is something. Okay, this guy's blogs are these two tasks. These two pages are very good. Technology is essential for the next decision. Now we're getting 300. I think that's it for today. We'll wrap it up here. Um, we'll continue with the plan. I'll spend some more time today, sometime, and actually I'll come up with more details if required. I'll talk to people on it, and then we'll move forward. Most probably we'll continue the because embedding anyways needs to be completed. So Elmo, BERT, based encoding and stuff will complete it, and then we're good with embedding, and then we'll move to the further tasks like TF-IDF techniques and all that stuff. We'll cover one by one, and then we will move forward, and finally reach transformer architecture, attention mechanism, and then LLMs. Then actually we'll go deep in LLMs on how the LLMs are trained and stuff. In LLMs, there are multiple models like GPT, Llama, and all that. So we'll see what is specific to each model, and then we'll go to the frameworks like uh, LangChain, Flowise, and all that. Then we'll get into start understanding agents and stuff. So this would take a long time. It's a long journey, but we'll keep our focus there so that we'll try to catch up soon. Okay, thanks. Bye, guys.